Okay, welcome. Hello, everybody. Welcome to this virtual seminar on native plant buy-ins presented by the Phytophthora and Native Habitats Work Group, the California Native Nursery Network, and the California Native Plant Society's ad hoc Phytophthora group. Over the next hour and a half, we'll be discussing the questions, are native plant sales byways for pathogens? And are there practical approaches for handling buy-ins? I'm Janice Alexander with the UC Cooperative Extension. I'm going to be your moderator for this program. To set the stage for our three presenters, I wanted to first offer some context for this issue. Despite continuing concerns about the movement of plant pathogens on California native plant nursery stock, this fall, numerous plant sales were held using stock grown by wholesale nurseries. The health of this nursery stock is known to be variable, and this stock, once sold, is commonly planted in landscapes where potential pathogen infections could spread. Still, the use of these buy-ins at plant sales and in landscaping projects persist. In an ideal world, all plants will be grown following practices we know limit pathogen spread. Our group is working towards that goal, including an accreditation program called AIR that would provide some reassurance about how plants are grown. There's also another program run by CDFA that aims to also have best management practices for clean plants. But those programs are nascent, and in the meantime, we need to have a discussion about how to manage risk when so many nurseries are not growing clean plants. And not to be glib, but the analogy that I personally use when I'm thinking about this situation is a needle exchange program. We don't want drug use to be happening, and we don't want nurseries to be selling unhealthy plants. But the real world situation forces us to acknowledge that these things do happen, and we need to come up with solutions to keep everyone as safe as possible. So what are the alternatives to buy-ins from these nurseries? Are there practical approaches to reduce the risk of inadvertent pathogen introductions? Our three speakers this afternoon will review several approaches currently being used to wrestle with the risk of plant pathogen introductions on native or ornamental nursery stock. We hope this discussion allows us all to examine the progress we're making and learn from practical experience. A few logistical notes. You are welcome to submit questions via the chat box. I will try to ask any quick questions at the end of each speaker's presentation if we're staying on time. If we're running behind or the question is lengthy and warrants longer discussion, I'll save it for the end where we planned a longer Q&A session. I'll do my best to get to all those questions, but if we don't get to them here, I will follow up with you offline if we run out of time. And if you need to pop out at any point, rest assured we are recording this session and it will be posted online afterwards. With that, I'm going to go ahead and introduce our first speaker. Krista Conforti is with the Presidio Trust, and she's going to be discussing the challenges and risks of doing pathogen screening on plants from non-accredited nurseries. And Krista, you can go ahead and share your screen.
So can you see my screen?
Not yet.
Not yet.
Sure,
okay, let me try a different route here. Okay.
I can see your browser now.
Now you can see my browser. How easily this worked.
And now I can see your presenter view. So
okay,
do that
and now
settings.
I need to do the trick that I did, which was,
I think it was display settings, and then you clicked on something underneath that.
Yeah, and I'm not getting the same thing this time. Okay.
If it doesn't work to show, I am seeing a screen that shows me your slides. It's just the presenter view, so it's not a total loss.
Shoot. Any different now?
Got it. Perfect.
Okay, Great, thank you for sticking that through with me. Okay, so I'm Krista Conforti. I am the Presidio Trust IPM specialist, and I'm going to talk briefly about the challenges and risks of doing screening plants for Phytophthora, for root-borne Phytophthoras on nursery buy-ins. So I'm going to try to do this in 15 minutes. I might go a little quickly. There should be time for a question and discussion at the end, but I am going to try to do this in 15 minutes. So here we go. Yeah, next slide. I think here we go. Nope. Oh man. I will say I do most of this stuff in Teams, so I am really not well versed in Zoom, but I will make this happen somehow. There we go. Do you see it? All right, first, let me orient you to the Presidio of San Francisco, which is where I work. We are in the traditional territory of the Yelamu, a local tribe of Ramaytush Ohlone, and Yelamu families lived here until settler colonists took their land. The Presidio is 1,400 acres of former military base turned urban national park. I work for one of the agencies that manages it. I work for the Presidio Trust. And a big part of our mission is to preserve and increase biodiversity. So we divide our landscape into 3 management zones. We've got our forest. So all these corridors of trees is what we call our forest. And then we've got our designed landscape zone. So all those areas around buildings, recreational areas, that's our designed landscape zone. And then we've got our native plant community zone, where we restore native vegetation and do habitat restoration. This park is home to 16 rare endangered plant species. 2 of them are pictured here. They're both manzanitas that are pictured here. And in both cases, the last known wild individual of these species lives in the Presidio. So we know that manzanita species are highly susceptible to Phytophthora damage. So these plants are some of the reasons why 7 or 8 years ago, we decided to start taking Phytophthora very seriously. So the first place that we focused on was our own in-house nursery. We did find Phytophthora in our nursery in 2014, and the nursery did a major overhaul of their best management practices and have not found it on our crops since. But our nursery grows almost exclusively native plants. We do grow a few species of trees that are used in our forest zone, but it does not grow the ornamental species that we use in our designed landscapes. We buy ornamentals from commercial nurseries, and many of those ornamentals go into landscapes that drain to the native habitat landscapes. And we know that Phytophthora moves well in water. So how are we going to keep the plants that we buy from these nurseries from harming the species that we want to protect in our native habitats? Since prevention is key, we decided to take an approach that involves testing plants for Phytophthora. And I don't expect you to really read this, but I'm just kind of walk you through it. This was our first attempt at risk management when it comes to buying plants. Any project manager who puts plants in the ground has to go through this decision tree with me to find out if testing their plants is required. First, turf, no testing required, not a significant host. But next, I ask who grew the plants that you're going to use. And if it was our in-house nursery, no additional testing is required. If it was a qualified grower, no additional testing was required. And let me explain what a qualified grower is. That's a grower who we have inspected their growing practices and verified that a list of 26 kind of must-have BMPs relating to irrigation, site drainage, potting mix, all of that, that they meet those 26 must-have BMPs. And so if you're a qualified grower, the plants that you grew do not need testing under this scheme. But if it wasn't a qualified grower, if it wasn't our nursery, well, let me back up and say that we called about 30 nurseries inspected 8 of them, and found only 1 of them qualified as a qualified grower. So realistically, only our in-house nursery plus this one qualified grower got that sort of get out of jail free card and didn't require testing. So the next question I would ask project managers is, will the plants be planted in our native plant community zone or in an area that drains directly to our native plant community zone? And if the answer is yes, then the plants needed to be tested. And so the answer was yes to this all the time. So I have tested a lot of plants and I have learned some lessons. And so let me just walk through the lessons learned with you. So testing is time and resource intensive. You will find things that you wish you had not. All testing methods are imperfect, some of them more than others. Testing is most legitimate as quality control on growing practices. Testing cannot guarantee that a batch of plants is clean. Testing is not a substitute for certification or regulation. And despite all of this, we, the Presidio Trust, still test plants that we buy. So now I'm going to go into each of these in a little bit more detail. So first, let's start with testing being time and resource intensive. So I'm going to tell you what it takes for me to test a batch of 100 plants, all same species, all grown at the same place, under our protocols. So let's say a project site that drains to the native habitat zone needs 100 Correa, and we've found a supplier, but that supplier is not a qualified grower, and now the Correa need to be tested. So this kind of outlines what I need to do. So in order to test those plants, I need to collect samples. That takes me about 45 minutes, not counting travel time if there is any, and uses about $1 in sampling supplies. Then I need to test those samples. And if I'm running rapid tests, and I'll describe those in a minute, the whole process takes about 40 minutes, depending on how hard it is to separate the roots from the soil, and costs $150 for 15 test kits. If I'm running pair baits, and I'll explain those in a minute, all the things that I need to do take about 1 hour and 15 minutes and cost maybe $5. But if at the end of that pair bait, there are lesions on the pairs that I can't confidently say were caused by Phytophthora, and that happens fairly often, I send the pair to a lab for confirmation to tell me if it is or isn't Phytophthora, and that takes me another 45 minutes and costs from $125 to $225. So this is all just to demonstrate that there's no easy way to do this, and each test type has pros and cons. And I'll say more about that in a minute, but before I do, I want to say that if you test, you will find things that you wish you hadn't. Over 5 years, I tested 412 batches of plants, meaning plants all of the same species that were grown at the same time at the same place. And of those batches of plants, 15% of them, about 15%, were positive for Phytophthora. And we detected 15 different Phytophthora species. One of them had never been detected in the US before. So if you test, you will find. So be prepared for that. And next, we're going to get into the pros and cons of the different test methods. And really, I'm going to talk about 2 different methods, rapid tests and pair baiting, but there are a couple ways you can do each method. So there's the rapid tests and pair baiting. So first, rapid tests. These are test kits that you can purchase to test small amounts of plant tissue for Phytophthora, and there are 2 brands that I know of, Agdia, pictured here, and Pocket Diagnostics. So I'll just kind of walk you through each of these. So the Agdia brand has a pouch that you can place a small amount of plant tissue, in this case roots, in the pouch and test it for Phytophthora. The pros, on the pro side for Agdias, they're readily available, they're easy to buy, and you get same-day results. On the con side, unfortunately, they don't only react with Phytophthora. There are some Pythiums that they give a positive result for as well, and you don't know when you get that positive result. Was it Phytophthora or was it Pythium? And since Pythium is less problematic than Phytophthora, that's not good. You want to know when it is Phytophthora. On the flip side, they also give what I'm going to call false negatives. And by that, I mean, you can only put 0.2 grams of tissue in each one of these tests. So unless you're running a whole lot of tests, you might not be testing enough roots to find it if it's there. And they cost about $7 per test. So because this kind of test, this brand of test has problems with both false positives and false negatives, I've stopped using it. I don't consider it particularly useful. But on to the next brand, Pocket Diagnostics. You can, on the pro side, you get same day results. On the not so great side, they are a product out of Europe. There's only one US supplier. It's a little bit hard, not impossible to get them. They don't have the same issues with false positives as the other brand, but they do have the same issue with false negatives, in that you have to run a lot of tests to test a sufficient amount of roots. And if you're not running a lot of tests, you might miss it. And they cost $10 per test. So running a lot of tests is very expensive. I do use Pocket Diagnostics sometimes, just because if I do come up with a positive, I don't have to move on to the next test, which is not quite as rapid, but is stronger. And that kind of test is parabating. And so I'm gonna kind of explain the way I do it. According to our protocols, when I run a parabate on plants that we buy, I collect soil and root from 20% of the pots in the lot. And then I put water in that sample, and then put a hard green pear in that water, and monitor it for about a week to see whether or not Phytophthora lesions develop on that pear. So on the pro side, supplies are inexpensive, sampling is easy, there's no false positives. And if my sample size is large enough or pathogen load is high, the chance of false negatives is reduced, greatly reduced compared to those rapid tests. On the not so great side, results can take a week or more. And it takes a fair amount of space and the right environmental conditions to run these tests, right? I need enough space, like undisturbed space, to store all these tubs with soil and root and pears in them. And I want to put them in fairly controlled environmental conditions, not too hot, not too cold. And I want a temperature fluctuation between day and night. Also, I need to do a lot of sampling to manage that risk of false negatives, and it takes training and practice to run these tests and interpret the results. You can't just put new people on this all the time. And if I'm unsure of the results on that pear, I have to send it off for lab confirmation. That's expensive. But this is the vast majority of the testing that I do. I use this method. But I want to mention that there's another parabate method where instead of testing soil and root, you test leachate that comes out of the group. It comes out of the bottom of a group of pots. And so this is the gold standard, because your sample size can be a whole bench. But you've got to run a very specific amount of irrigation for a very specific amount of time, and then run that parabate on the water that has moved through the pots. So for buy-ins, you generally can't use leachate testing. It would be too cumbersome to walk into a nursery and successfully perform this kind of sampling unless you have a lot of cooperation from that nursery, which you generally don't have. So I mention it because in a perfect world, all growers would be doing this type of testing on their crops to validate that their BMPs are working. So the pros are that supplies are cheap, no false positives, and you can test a large sample set at once, so the chance of false negatives is minimized. On the con side, all those same cons as what I previously described for soil sampling, but also you can't easily sample in a nursery that you don't manage yourself. All right, and now I'll just mention that there's work currently happening to train dogs to detect Phytophthora, but it's in the very early stages, and it's not clear how well it will work in a nursery setting, or if and when it does, how best to utilize canine detection. But we have high hopes, and stay tuned on that. All right, so since testing methods are imperfect, testing plants you buy does not give you a guarantee that they're clean. The testing methods available to you are not strong enough to always detect when a group of plants might have had a sorted history. So these are pictures that I took at commercial nurseries to demonstrate that if we knew the conditions that some of the plants were grown under, we wouldn't accept them. But when they show up in a sales yard, they look just fine. Like, for instance, I suspect there's something disease-wise going on in this Grevillea tray, but this individual right here looks fine and will probably get potted up and sold. And these 1 gallons don't look so great in context, but if they're on a sales yard, they're going to look beautiful. And our testing methods just are not strong enough to illuminate this kind of thing every time. So we need regulation or accreditation programs. And there are 2 such programs, as Janice mentioned, one that came out of the working group for Phytophthoras in native habitats, called the AIR program, and it's being adopted by many nurseries that specialize in native plants for habitat restoration. It's quite rigorous. Many native plant nurseries have or are going through the process to get this. It's a great program, but it does take a lot of effort. There's a separate program that's being through CDFA and their partner Norstuck, that several large commercial growers are in the process of going through. It's not as rigorous as the AIR program, and no commercial nurseries are yet certified, but there are large nurseries and maybe other nurseries in the pipeline. And part of these certification programs should include testing as quality control on best management practices. The AIR program does require quality control testing, but the CDFA program is looking into adding testing, but I don't think it's a current requirement in their program. And so this graphic just shows you the quality control testing from our nursery. In 2014, we did detect several Phytophthora in our crop. Then the BMPs were improved and we have not detected it since. So this is just to say that testing really should be used by growers themselves as a check on their growing practices, not by the buyers of those plants in an effort to find clean plants. So after having said all that about testing being imperfect and really best used at the growing site, why am I still testing plants that we buy? All right, number one, we don't have the option to buy most of the ornamental species our designers want from growers participating in certification programs. Those growers just don't currently exist. Number two, it does reduce the movement of pathogens. We do detect Phytophthora, we do reject those plants. And number three, it puts pressure on growers to participate in certification programs, and that's ultimately what we want. And I use these pictures here to acknowledge that it does cost more to run a nursery like this, which is ultimately what we want. So if, in order to get what we want, I think we probably are going to have to accept a higher price per plant. All right, so I told you our first attempt at risk management. Now this is our second attempt at risk management. I'm not going to walk through all the steps, but just to say that we stopped designating nurseries as qualified growers and instead came up with this idea of a qualified grow, where if you're growing a large batch of plants for us and we can have our plants grown in a specific part of the nursery with very specific controls happening, then that would qualify for not testing. Otherwise, if you're planting into the native plant community zone or an area that drains to the native plant community zone, we have a list of high-risk hosts, and any outside nursery growing those high-risk hosts, those plants need to be tested. So this is we put this list together based primarily on all the testing that we've done. So testing of incoming plants and testing the Presidio landscape. So if I've tested a genus more than 6 times and it has a positive rate of over 15%, it goes on this list. So this system puts pressure on project managers to steer away from high-risk host plants because it can be very hard on a project's timeline and budget to build in for the uncertainty of trying to find plants that test negative. And until we get widespread participation from ornamental nurseries in good certification programs, I do think we're going to be in this uncomfortable position of using imperfect testing methods and/or staying away from high-risk host plants. All right, one last point that I want to make, which is over the course of learning all these lessons, we've done a lot of outreach and education. These are pictures of 5 interns I worked with over the course of this work, and 4 of them are still working in the field of land or plant management. And they're carrying this idea of the importance of preventing the spread of plant pathogens into their careers. So while this seems daunting to all of us, I do hope that it will be kind of more built into the next generation of nursery operators and land managers. And that is all I have for my 15 minutes.
Thank you so much, Krista. I'm going to try to squeeze in 2 hopefully quick questions for you. Pam asked, is there any movement or interest towards using only natives in your landscaping?
So yes, this definitely has, I mean, we always said we were interested in it, but there is it's not a conflict. It's just sort of, we have these distinct management zones, right? And so in the designed landscape zone, we said that we would sort of honor the design that was here when it was a military base. So there's sort of that pull to not use natives, but also this push to use natives because it just makes sense for us as a national park site. So I think this effort to try to reduce plant pathogens has pushed us more in the direction of using more natives, but we're not exclusively using natives in those areas, and we don't have commitment to use exclusively natives in those areas. But I think we are pushing, we are moving away from using high-risk hosts and moving toward using more natives.
Great. And I'm going to ask one other quick question from Stephen. He has said, you said you improved BMPs after testing some positives. What BMPs did you add?
Oh yeah, so that's a whole presentation into itself, but we, I say we because I was peripherally on part of it. I didn't do most of this work. Our shade house had problems. The shade house floor was not in good shape, so we had to redo the shade house floor entirely. We entirely changed the way we clean pots before reusing them. We bought a steamer and an aerator so that we could pasteurize our potting mix. We drastically reduced foot traffic in and out of growing structures, and implemented the use of isopropyl alcohol or foot baths going in and out of them. So those are the sort of top tier things there, and there are others, but yeah, it was a significant undertaking.
Awesome. Thank you, Krista. I'm going to save this other question from Jessa for a little bit later so we can move on to our next speaker. I'm going to now introduce Betty Young from the CNPS Milo Baker chapter, who's going to review how to buy plants early and pre-screen them for Phytophtheras. Betty, take it away.
Hi, everyone. Thanks for joining us today. It's really exciting to see so many people here. Let me share my screen. There we go. I'm speaking from the point of view of our CNPS chapters, but I think a lot of the information will apply to many of the other people that joined us today. We have CNPS, California Native Plant Society chapters throughout the state. And for many of us, our plant sales are our main source of income that support our conservation work. And plant sales also are a means to encourage public use of native plants in their landscape. So here we're talking supplying landscape plants. But our chapter has built its own nursery, but most chapters don't have the resources to do that. So I'm going to talk a little bit about buying in plants and how hopefully we can buy them in soon enough to test them, to use pair testing, which is fairly cheap, to at least partially assure that they are probably clean. At least it's more assurance than what we're providing now. Okay. This one. Okay. So as most of you probably know, but I'll just review as a reminder, what nurseries do, whether it's a large wholesale nursery or one of our small nurseries, is battling spores of Phytophthora. They can be in the potting mix that was used, in reused pots if they were not Cloroxed or pasteurized, steam pasteurized before using. They could be in cuttings, infected cuttings that were stuck in seed media, in infected divisions, or media that's used for either seed or cutting propagation. They can splash up from the ground. Sorry about that. They can splash up from the ground. And our challenge is that wholesale nurseries that we may be buying these plants from pretty much uniformly use fungicides because they aren't using perfect growing practices. Those plants sitting on the ground that Krista showed are just perfect condition for water to run through and infect the plants. If they're not pasteurizing their soil, the media could be infected. And so they use fungicide that suppresses the germination of the spores, but it doesn't kill them. And many of the fungicides can last up to 90 days in the pots. So we sell those plants at our plant sales with spores that are ready to germinate 2 months after our customers get them home. So we need to hold those plants. If we can't buy from a certified nursery, then we need to hopefully hold those plants for 60 days and then do the fairly cheap, but a little bit time consuming pair testing method that Krista talked about. So that's the trick for most of our chapters, is how do you hold on to plants for 60 days? If you haven't, then you need an isolated area where those possibly infected plants can be kept for 60 days away from your clean plants. So this is our lovely quarantine area in our nursery. But if you don't have that, if you're buying in plants now, one day for your sale, and they're getting sold the next day, you may have them delivered to wherever you're having your sale at, and then the next day selling them. You need to back that up 60 days and figure out a fairly cheap and easy way to hold those plants for 60 days until we can test them. So this right-hand picture shows a fairly cheap method to make a bench, which you could put in members' driveways or in some other area that you can keep the plants up off of the ground, because if they're on the ground, they will get infected from water running through infected soil and then into your pot drainage holes. So these should be 2 concrete blocks high. We want to be at least 30 or 32 inches off the ground. If I'm wrong, Ted will correct me. So this is this wire on the right side is called hog wire. This is a picture from a local nursery here in Santa Rosa, near Santa Rosa, that grows pretty much all natives and is upgrading their facility as they can. So in the last 2 years, he's put these kind of benches in. You could do that in your backyard. Keeping those plants up off the ground, hanging your hose up on a hook, at least that high up off of the ground, keeping a brush to keep your bottom of your shoes clean, and a bottle of alcohol to spray the bottom of your shoes. Wear exam gloves when you're watering or touching your plants or the soil in the plants. And that's, fairly cheap and easy. So, and we also, even though we have a nursery, and with one last go around with Ted to get our certification, we hope he'll be satisfied with our 60-day holding procedures this year. We buy in plugs like the ones on the left of rooted cultivars that people want, because we don't have a good facility to do root cuttings. And here is Calflora Nursery 4-inch and gallon cans that could be held. So whether you're buying, the trick is I can't hold a plug this size, which is only like 1.5 inches deep and 1 inch wide, for 60 days until I'm sure the fungicide has decomposed and the spores are germinating if they're there. And so that testing would be effective. Testing while there is still fungicide, which I'm sure Ted will remind you, is useless because the spore germination has been suppressed. So we've got to wait 60 days and then test. So what do we do with those little plants that we're buying in? If you're buying in plugs, you can pot up to 4-inch or 2-inch up to 4-inch to hold 60 days. If you're buying in 4-inch pots that you're going to pot up to gallons, you can hold them in 4s if you ask the nursery to ship them to you before they're too grown in. Same thing with gallons. You can ask them to ship the gallons after they've been transplanted for 2 to 3 weeks. So the roots have gotten established, but they're not root bound. They'll hold for 60 more days. Or ask them to, which good luck with this, but ideally, ask them to stop using fungicide 10 weeks before your shipping date. And then after it, and then ship, and so you could test them right away, or buy from a nursery that doesn't use fungicides like Calflora here in Santa Rosa. Boy, they're getting a lot of free ads here. And then test those. They are not a certified nursery, so their plants still need to be tested. But at least they don't use fungicides. If you're not potting up smaller plants into pasteurized media, then you need to, if you're buying in smaller sizes like we talked about, and not putting in pasteurized media, then you need to go ahead and pot them to gallons. So when you do test them, you're testing the media that you will, all the media that you will be selling, because you could be potting up into contaminated media. And then how do you do pair tests? So Krista showed one picture. This is training that we took from Ted, that I took from Ted. And it entails an igloo container that you drill out and put a pipe in, and all the instructions are on Ted's Wiki's website. It's Phytosphere. But you can, with this simple sheet to catch the leachate under the pots, you can test about 20 gallons at a time. And hopefully that's your whole crop for most of our plant sales. Or it's a pretty good portion of your whole crop, so that if that test comes back negative, you're pretty sure that you're going to be selling clean plants. As limited as the testing is, each thing we can do is giving us more confidence that the plants we're selling are clean and we're not putting Phytophthora out. And here's another picture, like Krista showed you, of the plants after the testing period. So the plants are watered according to a protocol. The leachate goes into this igloo bucket with a pear in it, floating in the water, floating in the leachate. And then that leachate is poured into a Ziploc bag, and you leave it for 3 days in the Ziploc bag, and then you rinse the pear and put it on a paper towel for another 5 days, and then you get a final reading. The 2 outside pears here came back clean. The middle pear, you can see the blemishes there. That was infected, and we dumped that crop that from those plugs. So it's pretty easy, and with experience and Ted's support, thank you so much, Ted, for looking at all our pictures of questionable pears. You get a little better indication of whether you're selling clean plants. Or you can build your own nursery, which can be done with, here we built a nursery. We had a partner organization that does restoration in Sonoma County. We both needed a nursery. So we went together to split the cost and share the nursery. We built it all with volunteer labor. It took some work, but it's doable. And then if you can find someone to manage the nursery using the best management practices and get your AIR certification, you can sell with pretty good confidence that sell clean and healthy plants like we did here. So thank you very much.
Thank you so much, Betty. Before I let you go, you had mentioned when you were talking about pear baiting, you had mentioned a website, and someone was asking you specifically the website you had mentioned. I can put it in the chat if you just remind us which website that was.
Well, Ted could probably remind you better. It's his website. I think it's phytosphere.com, but I'm sure he'll mention that. Okay. And maybe even have it on in one of his slides.
Well, what a fantastic transition you've provided us. So I'm going to say goodbye and thank you to Betty, and we can get to some of these questions that were from her talk when we go to the end. And I'm going to move on to our final speaker, who is Ted Swickey of Phytosphere Research. He's going to provide other guidance on plant handling and review a bit about the Accreditation to Improve Restoration, or AIR program, that we've mentioned a few times. All right, Ted, go ahead.
All right, then. I take it I'm audible. I'm going to try to share my screen without too much drama this time. Share. All right, so the question is, which screen do you have showing, the presenter view or the other view?
I see the presenter view, so if you can do the display to the other.
Okay, does that work?
Yep, looks good to me.
All right. All right, so I think we had a couple of good talks already, and we're going to kind of amplify and talk about some variations on some of the same things. If I talk through a nursery stock is kind of the big question, what are we going to do about it? And well, we actually can read online that plant pathologists have a solution. Sure enough, and it's not actually as critical and as difficult to think as you might think. Basically, grow clean plants, right? Start clean, keep it clean. Pretty straightforward sort of thing. That press release was related to this paper we just published on the accreditation program, the AIR accreditation program, which was also is up available at that website there. It also was a editor's pick from that journal, so we got a little extra street cred things going with that as well. But basically, even I'll refer you to that paper. Is a good thing if you don't know about the program at all. That summarizes a good bit of history and how we got to where we are and where we are as of just as of earlier this year, really. So let's look at it this way. If we're running a Phytophthora BMP compliant nursery, a clean nursery like Betty's or the Presidio nursery, what's the maximum amount of Phytophthora that we want to allow in our nurseries? And just a couple of seconds to think about the answer. And of course, the answer turns out to be the same number as the number of rabid skunks you want to have running around your house. Okay, you want nothing, right? Because a nursery is a very conducive place for Phytophthora. So if you're trying to grow clean plants, you really don't want to be in a position of bringing Phytophthora into that nursery. This is kind of a busy graphic, which we've used before, but bottom line, if we think about disease epidemiology, there's the plant disease pyramid, which is two components of the environment, the abiotic and abiotic, the host and the pathogen. All those things interact over time to produce the potential for disease. And all the conditions in nurseries are essentially always favorable for the production of disease caused by Phytopthora. So nurseries are just optimal places for Phytophthora to get going and to persist. So we really have to draw a pretty strong line about how much we have in there. So this is just an example of this. Some of you have probably seen this graphic before. We had this flat of Prunus ilicifolia that were grown under clean conditions. We inoculated the center one, left them out in the greenhouse bench to be irrigated normally. Came back after a few months. You see some of the plants look like they're still fine, but some of them don't look so fine. If we actually bait these all individually, we find that almost all of them, with the exception of these three, baited out positive for Phytophthora. These are the three. Two of those were already dead and probably dead too long to actually be detected anymore. And the very corner one in the front, maybe that was an escape. Or maybe we just didn't have enough inoculum yet to detect it. Testing is not complete. But there was a question before, what about, can we tell symptoms, which plants are infected? Well, all these plants are infected. They look pretty good in general. And that's one of our problems with nurseries, is that we can have plants that look good that could be infected. We could have some plants that look bad, but maybe they're looking bad because they go dormant this time of year. Maybe they have other issues. Maybe they weren't watered properly, et cetera, et cetera. So can we really pick out, when we're looking at the nursery, which ones are infected and which ones aren't? Not with any great certainty, but certainly starting with ones that don't look very good is a good place to start about if you're thinking about trying to select plants to be tested. So the air system, or the accreditation to improve restoration, the program is based on complete exclusion of Phytophthora from nursery stock and its inputs. So not less Phytophthora, no Phytophthora. And that is the difference between this program and virtually every other program that's been attempted in nurseries, because virtually everything else is assuming that, well, there's going to be some Phytophthora around, but less Phytophthora is better than more Phytophthora. So that's okay if we have some. And this kind of illustrates that. This is a table from our paper that I mentioned. And I'm going to just rearrange it into an easier to look at way for the screen. We have here a bunch of testing of the type that leachate testing of the type that both Betty and Chris have been talking about on these tests. You can see we started testing back in 2017 on some of these nurseries. These are all ones that are compliant with the nursery Phytophthora BMPs. And as you can see, there's really no Phytophthora to be detected in these things. We look at partially compliant versus generally non-compliant nurseries. Nurseries that are doing some things that are acceptable, but other things not so much, versus other ones. We say, okay, well, we have some reduction potentially in the incidence of Phytophthora. And you might think that's okay, but again, we'll look at kind of a silly example, but you're driving your car down the freeway. How many angry hornets would you like to have in your car? Would you rather have 71? Would you rather have 25? Or would you rather have 0? There are some things that 0 is the right number to have, because anything above that is causing problems. There is one nursery here. We're going to talk a little bit. We did some extra testing in, but when it was first tested, we just did a small number of tests there, and there were no positives detected. And we've talked about the limitations of testing in some of these other talks. We went back, and due to request, we did a lot more testing in that nursery, and you can see that once we did more testing, we had a lot more positive results showing up in terms of Phytophthora detections. And I'll be going into some detail on that because it illustrates a couple of points a little bit later on in the talk. We already seen lots of pictures of this, but just to give you the ideas, we can bake rather large plants. We can go up to number 15s. We haven't got anything larger than that. We can get 1 gallons. We can go down to little tiny containers, and there's some variations on the equipment you can impose in these different situations. Eventually you end up with this at the end of the test, a pear that has been already exposed to inoculum during the test, and it continues to be exposed to it while it's incubating, and positive results can look like that. But we did a lot of testing on this methodology to try to figure out what was its efficacy, how sensitive was it. And we do know that it's affected by the size of the test array and the batch infection rate. And so this data here basically is our detection probability function based off a number of experiments. The bottom line is that there's not many infected plants in your test array that you're testing. Percentage-wise, your detection rate is not going to be very high. If you have a really infected batch, it turns out that it's pretty easy to detect it. But if we're down here at the 1%, 2%, 5% level, you have to run a lot of tests to have any kind of confidence. But the bottom line is, you have a higher infection rate, you have more likely detection. And this is how this interacts with infection rates. So these are going to Leachate tests. This is a modeling based off that data. And we're going to look at testing a lot of 1,000 plants that has a 1 or a 5% infection rate. We'll start with the 1% case here. So that means we have only 10 infected plants in this 1,000 plants. Okay. So if we don't include any of those in our test, we'll always end up with a negative. So we're looking partly on the probability that we actually get these infected plants into the test to begin with. And then beyond that, what's the probability that if we have 1 or more there, we actually get an actual detection? And one way to increase your efficiency, which this shows, is that if we test multiple arrays, so instead of just testing, so these are numbers of plants in the test, and this is how many times we replicate it, 1, 2, 3, or 4 arrays. And the last thing on this graph is bias. If we have no bias, or the bias 1-to-1, we have which is basically random sampling. We're just picking plants at random and saying, okay, we're going to see what our infection rate is. And that turns out to be the most inefficient way to do detections, because you have to basically rely on luck that you actually get these infected plants in. And you can see that if we are on a single test, even to 40 plants, we have less than a 20% probability of getting a detection under this modeling scenario. Whereas if we can sample plants that are more likely to be infected and we bias it, this is biasing it by twice, this is biasing it by 5 times, saying we're 5 times more likely to have gotten the infected plants by our choosing than by just randomly sampling. You can see our detection efficiency goes way up, and it really is improved again, still by having more multiple tests of these batches of plants, not putting all the detection based on one test. In general, as our infection rate goes up, here's 5% infection rate. We have a lot more infected plants out there. And even under random sampling, our detection efficiency improves, but you can see you're still improved more by running multiple tests. And the bottom line is that there's some leveling out that eventually occurs at some point, depending on how infected the batch is, that after a while, it doesn't matter how many more you test, your detection efficiency is going to top out. So how's this all kind of play out when we're doing things? So all this is in mind when we went back to go test at this nursery. We'll call it Nursery K. That's what it's listed on the plate. And we're testing material in all kinds of sizes, little dinky stuff, and all the way up to 15s. These are just 5 gallons, number 5s. And we ran over the summer, we ran 139 tests there. 128 were leachate tests, 11 were root soil type tests, so similar to the type that Krista was talking about. And our overall detection, as you can see here, a little over almost 16% in the leachates, higher percentage in the root soils, but there are fewer of them for this overall 16.5% positive rate. If we just look at the leachate tests only, just to keep it simple, so we're just looking at this column. We take a look at where these plants were growing in the nursery. This was not a fully compliant nursery. They were a nursery that would easily have probably met all the CDFA BMPs, but not the air BMPs. And basically, they had material not on the ground, but on pallets. But you can see the 26% infection rate of that material compared to 2.8% of the material that was growing on benches. Container sizes, you should know that when you're getting material from someone else or growing it in the nursery, the longer it's in residence in nursery, there's more risk of contamination. And as we see, these larger container sizes on this side, we have higher infection rates, and the smaller sizes of containers, which are also younger containers, things that haven't been growing as long, there's lower infection rates, but not impossible to have infection at these things. Beyond that, there's an interaction with what was being grown. A lot of the material in the smaller containers were monocots, a lot of grasses and sedges, brushes, etc. And the monocots in those groups in general, seed produced, essentially we didn't have any detections in. As we look at these dicots groups, you can see that the woody perennials had the highest infection rate overall. And if in fact we take out the monocots, we can see that our overall infection rate jumps from 15.6 up to 18.5% for these 2,400 plus plants that were tested. It also turns out that this particular nursery, which didn't totally control its own fate, it was doing stuff under contracts and had a lot of other influences, but they were required to bring in some material from some other nurseries. We tested, and we just look at the woody plant material from that set. We only ran 3 tests, all of them were positive, and we had 6 species of Phytophthora just from 3 tests, basically in that, compared to 36 tests of the same type of material with a 30% infection rate, which is still really high, but only 3 species of Phytophthora. So one of the issues you have if you're bringing in material is that it's bad enough if you're, if you're a clean nursery, you don't want any Phytophthora. But when you bring material in from other nurseries, you're going to greatly increase the diversity of Phytophoras that are in the nursery or in the environment of the nursery. And that just gives you more opportunities for issues down the way. So everybody who has a nursery that I've ever talked to, there's never been anybody who said, oh yeah, I run a sketchy nursery and I've got all kinds of practices that are doubtful. I mean, everybody thinks they're doing a great job. And in their own mind, they may well be, but not all these standard nursery practices are compatible with growing clean plants. And so, yeah, you can go down and you can make a check, you can ask people, are you doing these things? But their program is based off of a much more rigorous evaluation. The nursery evaluation form, and these are some extracts from it shown here, has got 11 topic areas, about 220 items that we're asking the nursery to comment on, and another 46 that the evaluator directly inspects themselves. Besides the fact that the evaluator also then looks at each of these responses and then rates it based off of how the answer comes out. And this is the rating scale we use, this GYOR, green to red scale. And really what we're looking at is there Phytophthora risk associated with these practices? And ideally, we want everything to be in the green category. And for a compliant nursery, that's exactly what we get. And we, by page under each of these categories, we kind of sum it up and decide, okay, is there any undue risk associated with this? If not, we have a nursery that is accreditable, and that's how the AIR program set up. So we have accreditation, but we still require testing. It's, to us, it's the whole point of testing is quality control. And if you never test, then you have no idea about your quality control. So to say we follow the grand list of things is great, but let's see some proof of that. And so, you know, it's a trust but verify situation. We want to have a clean production process, and that's where the all the risk is reduced. But testing serves as a check, and really, because it's non-destructive testing, you can test as much as you want. And really, we always suggest that even for AIR certified nurseries, that clients do a certain amount of their own independent third-party testing. We would never suggest that they totally just rely on what's going on out there. I think you really want to make sure that everybody in the process has got some kind of well, they got some skin in the game. They have to be able to say, yeah, we tested this stuff. We're sure it's going to test clean. You can come in and test it because we've tested it ourselves. We know it. Not the situation where Krista was describing, where effectively they were opted out. So the AIR program itself is based on detailed science-based BMPs, these nursery evaluations to assess compliance, and then testing for quality control as part of that. And our objective here in the program is not to screen out bad actors or whatnot. What it is to try to get nurseries to actually achieve the objective of being able to produce clean plants on a consistent basis. So we're really working with all these nurseries, looking over their issues, coming up with ways that they can address them, working within the confines and the constraints of each situation. So there's a lot of outreach that's associated with this program to try to help these nurseries become successful at being able to do clean plant production. So our overall goal in this program is that we really want to protect native vegetation and habitats to make sure that nursery stock that goes out into these sites doesn't serve as a source of Phytophthora introductions. And that's the situation we have here, planting done with infected material. Of course, the infected material started to die immediately, but this material down here is a native species downslope from the planting that is infected with one of the species that was introduced in this planting. And we know over time, we can have devastating effects on native forests and other native vegetation types associated with Phytophthora. So this is what we're really trying to avoid by really going with the no tolerance type of approach to Phytophthora being introduced by a nursery stock into these settings. I think that's the end of the show, so I'm going to stop sharing.
Thanks, Ted. I wanted to ask you a couple of follow-up technical questions that came in the chat. So they're all related to this biased sampling that you presented.
Mhm.
Robin wanted to know how you know which plants are more likely to be infected to test those in your bias sampling scheme.
Okay, so we can bias based off of a couple of things. One of them is appearance, okay? So if we've got a batch, given that if we were going into a nursery with everything on the table, the first layer of bias would be by what plant taxa we would be looking at. So if I'm going into a nursery that we haven't looked at before, I'm not going to run right to the grasses and test them first because they're the least likely to be infected. So we're going to look at first higher risk material, and up to a point, Krista has got something worked out along that line. In general, I wouldn't limit things to individual species so much because it turns out there's a lot of things that are not documented out there. But once you then narrow it down, okay, we want to test these frangulas or whatever else it is. The next thing we look at is symptomatology. Okay, so do we see any evidence of root rot type symptoms, which means the plants look like they're water stressed, they've been growing slowly or poorly, they got early leaf loss, any other sorts of things. Those types of symptoms generally don't show up until there's a lot of infection that's been going on. So those are types of things that you can certainly look for, but they won't always be there. But just growth differences and unevenness and the things, and particularly if there's patterns to it. And then finally, if there's nothing else that's really obvious in terms of this thing, the last thing you kind of work with in terms of risk is, okay, which way is contamination most likely to work its way into this? Is this adjacent to another batch of plants that could have splash over? Is it adjacent to the aisle where people are going to make more contact or more splash is going to be, as opposed to the far side of the bench? So that's what we call sort of positional bias, that we can bias for the position on the bench or in the nursery to say, okay, these plants around the edges or whatever probably have a little higher risk than those that are farther away. So that's how bias works. So appearance first, and after that sort of position.
Great. And then just one more technical question. Linda asked, to do random sampling of 1,000 plants, how many actual plants are chosen for the testing group?
Let's try to quite understand the question here. If you're random sampling, I mean, in this particular methodology, we tend to, based off of the data we have, we generally don't increase our sample size above about 40. You can go slightly over 40, go 42 if your things are in 7x7 blocks or whatever, things like that. But as we get to higher and higher numbers, you end up with the possibility that if you only have one, if you do get one and it's in this large array, your detection efficiency is going to go way down. So if we're limiting our batch size to 40, but we want to test a lot of things, we test multiple batches of 40. So we wouldn't try to test 120 at once. We would test 3 separate batches of 40, or we could test 4 batches of 30 if you want to look at it that way. So that governs that. But again, we wouldn't try to detect, we wouldn't go in there intentionally to go random. We would still try to bias at least positionally. If everything looked good, you would at least go for positional bias before you would sort of bump down to fully random.
Okay, that's great. Thank you. I'm going to move us into more of a Q&A, but I want to get back up into some of the questions that we didn't get from earlier speakers. So this came in while Krista was speaking. And so this might be something for Krista, though Betty or Ted obviously can jump in. So Jessa asked, has anyone had experience with requiring testing for a contract grow with a native plant nursery? What percentage of contracted plants would it make sense to test?
I can say that we have had a contract grow that required testing. It wasn't for native plants. And it depended on the batch size. So somewhere around 20% of plants would be included in a test. Does that answer the question?
Yeah, I might just throw in the idea that it's hard to put just a number on how many plants you test, because plant batches can range from, a dozen or less to thousands and thousands. So clearly, if you've got a small number of plants, you have 80 plants or whatever, you could 100% test those. It wouldn't be that difficult. You could do that in 2 tests. If you had 1,000 or 2,000 plants, it's not so easy to test the whole thing. So then you are usually kind of testing up to your resource limitation there. And then also a function of what's the risk associated with it. So if we're dealing with a lot of direct seeded grasses that are low risk hosts, obviously that's something where you're not, there's relatively low risk. You might still test them, but not worry about hitting a very high percentage. Whereas if you were working with something like toyons, which are notoriously infected in nurseries with Phytophthora cactorum or hydrangea, you might want to have a higher rate. But there's one thing in particular that we used to our benefit in this testing at Nursery K, which is if you have multiple tests to run, there's kind of 2 ways to do it: to run them in parallel on the same day or to run them on separate days. And as it turns out, when you're working with a non-compliant type of nursery, you're better off scattering across things and getting your first test in on day 1, say, and then do the replicates on later days, because if test 1 comes out positive, you can skip the rest of the testing. You're done, basically, because you're going to reject that batch. So there's a part of it is by means of strategy, you can kind of minimize the amount of tests you do. In a very clean nursery where that's unlikely to happen, there's no disadvantage to testing, say, the whole batch in one day.
Great, thank you. A couple of different people asked this question about any of the Phytophthora species being native to California. And I think the implication there is whether or not that makes them as worthy of concern.
Yeah, I'd like to address that. At this point, there are no solid data that indicate that we have any known native Phytophthora species. There are probably a lot of Phytophthora species that are long established in the state, and they may have been established going back to European colonization back in the 1600s or when that occurred. So that is one thing. But even if we had a area where there was some native Phytophthora, if it was native to some little area, once you're outside of that area, it's exotic. And the example of that, another example of that is gold-spotted oak borer. It's native to the southwestern US, but it's native to really a certain mountain range in certain mountain ranges in New Mexico and that area there. Moving it to California caused tremendous disruption to native oaks in that area because it wasn't native to that area. So I don't think that a lot of people would like to be able to prove, yes, there are native Phytophoras in California or whatever they were and whatnot. And it's kind of a moot point, because the point is these are not going to be Phytophoras that are native to the whole area anyway. If they're to some given habitat, and they're going to be aquatic situations almost entirely, that's the type of thing that once it's out of that is not native anymore. So I think that's not really an issue to put on the table as an important one.
Great, thank you. Okay, so Ted already covered a fair amount of this about what the AIR program covers, but Pamela had asked, what are some of the key differences between that program and the CDFA's voluntary accreditation program? And I'm wondering if any of our speakers know enough about the CDFA program to talk about what differences exist.
Well, Well, we know a certain amount about it. The main difference is that air is pretty much prescriptive in terms of, okay, these are some things that you need to do, like have your benches at least a certain height, use heat treated or otherwise known clean material, potting media, et cetera, et cetera. Almost all these other systems, including CDFA, are permissive on things like that. It's like, this is preferred, or, you know, this under certain conditions, this might be better, or, you know, this is best, but at least have it off the ground. Well, sort of like we showed on that one thing, having plants off the ground on pallets was worthless in terms of disease management. So the main thing is that we have kind of a zero tolerance situation, whereas CDFA, we've seen their reductions of the BMPs into their version, and basically they're gutted in certain areas that mean that you don't really have exclusion anymore. You're still going to allow Phytophthora into the system.
Krista or Betty, do you have anything to add in about how the different programs work, or how you would compare them?
No, I'm sorry to say, I just don't know enough about the CDFA program to really say. There might be people on this call who know more than I do. I will say that when we did our qualified grower search, we used criteria that were less than the AIR program. And the reason we moved away from the qualified grower model, I don't know if I said this in the presentation, is because I was testing plants from qualified growers as they were coming in, even though they didn't need to be tested, to see whether or not they were in fact coming up negative, and I was finding Phytophthora. So they were getting through, but I found them at a lower rate, a significantly lower rate than non-qualified grower plants. So again, you know, to Ted's point, if you're a nursery, you don't want to have any Phytophthora. But from our standpoint, planting out in the landscape, we accept that we're not at that point to be able to buy no Phytophthora, and we would like to slow it down, so that while that qualified nursery designation that we were, you know, doing on our own ended up not being useful for us. I think I did see that there was an impact, but it wasn't enough to keep it going, and the fact that we only found one nursery that could meet it.
Yeah, I would like to add, unless Susan's still on Zoom, she's probably best qualified, involved in both programs. But I think Ted touched on it in detail, but I think the basic differences in the AIR is the AIR program requires plants be grown in such a way that plants will never become infected. The CDFA hopes for that, but will allow non-pasteurized soil, potting media, and the use of fungicides, and possibly reuse of pots that are not disinfected. It's a reality in large wholesale nurseries. If you have a 400-acre nursery, they're never going to get their plants up onto properly benches of proper height, and they're not going to be able to pasteurize, you know, 500-600 cubic yards of soil every week or two. So with that in mind, knowing that wholesale nurseries will practically never be able to meet the AIR standards of all pasteurized media, disinfected pots, then how do you work with them to hopefully get the best product, the cleanest product possible? So their CDFA program hopes to encourage as many best practices as possible to reduce the risk. Obviously, we want 100% Phytophthora-free plants, but given that wholesale nurseries as they are now can't meet those criteria, then how do we work with them? Or how does CDFA work with them to do the best it can? And that's what I was trying to address is, assuming you're buying from those nurseries, then let's at least wait till the fungicides are gone and then test them to see if they're clean before we sell them.
Yeah, and actually, I put it down in the chat just to clarify that, and again, these fungicide residues, it depends which fungicides are there and whatnot, and they can go out. Actually, 60 is not a magic time. If we're looking at something like phosphites, they can go out a lot longer. But you also don't have to wait 60 days before you run your first test, because a lot of the Phytophthoras and nurseries are resistant to some of these fungicides, and they don't work that 100% anyway. And that's why things keep spreading in nurseries that are being sprayed with fungicides all the time. So one thing you can actually do, again, sort of like this successive thing, you could test this stuff up front after you get it. If you have any positives, dump those right now. If they test negative, then you can wait your 60 days and to retest them. And that way you aren't holding on to stuff that you could have detected in the first 2 weeks that, oh yeah, this stuff is infected. We might as well get rid of it. And so that's what I would modify your program to do, is to go ahead and front load some testing, but realize that if things pass, that's not the final word on it. And you really want to retest these things anytime you have a negative, especially from a source that's sketchy like a commercial nursery.
Thank you. I wanted to follow up with a question that wasn't in the chat, but came in ahead of time with registration. Someone had asked, what is the best way to ascertain the level of BMPs being followed by a nursery that we buy plants from? I wanted to just put a plug in that we did come up with, the working group did come up with a guide for CNPS chapters on how to look at nurseries. I'll put the link in the chat right now so you can see that. But while we've got the speakers on, if any of you guys want to talk about how you work with a nursery to understand which BMPs they're actually following, so you can feel more confident about their practices.
Okay, I'm going to start back kind of where I was in my program. Unless a nursery is actually trying to comply with air level types of BMPs, it's not a clean nursery. I mean, just a fact. I mean, the air nurseries, no Phytophthora, other nurseries, Phytophthora is there. So it's sort of this question of, okay, well, how much Phytophthora are you willing to tolerate? I would put out that the argument is that the better analogy to Phytophthora is like a pollutant. It's an environmental pollutant. It's a biological environmental pollutant. And so how much pollution are you willing to put up with, and how long are you willing to put up with it? The thing about a biological pollutant like this is that it is also self-propagating. So while you can dilute mercury out of groundwater or something by letting it percolate down far enough, et cetera, you can't make these other things go away. So you're eventually going to degrade whatever site you move these things into. And I understand that everybody's saying, well, let's be realistic, but realistically, we should never stop burning fossil fuels and just let the earth go up in a cinder, because it's too much trouble to stop doing that. There's a lot of things that are difficult, but because they're difficult doesn't mean they can't be done. And so that's what I think the AIR program is trying to show, is that here's something that has been understood to be difficult for a long time. And yet, sure enough, we've got nurseries that are managing it. So that means we have to change our paradigms about what size plants we use and how we propagate these plants. Maybe we do. But in the end, that's what's going to get us to a situation that is stable and sustainable, is growing clean plants and not just trying to reduce the amount of Phytophthoras, because it's an unending morass of more Phytophthoras out there in the standard nursery production. So a little sermon, but I think it's an important point here that we can compromise up to a point, but the reason AIR program is successful is because we eventually drew a line and said we cannot compromise on these standards. If we compromised on the standards, we would have a program like every other one, which is not successful.
I don't know what to add to that, other than to say, yeah, we tried to screen nurseries over the phone. That did not work. Tried to screen them in person, and that worked better. But again, we detected Phytophthoras from nurseries that when we went to their sites, our checklist, which was not as rigorous as the AIR program, was not sufficient.
Betty, do you want to add in anything about how you've talked to other nurseries, or are you growing exclusively on your own now?
We do buy in plugs of rooted cuttings from a nursery that, I mean, any nursery that's growing just propagules is shooting itself in the foot if they're not using pretty clean practices. The nursery we buy our rooted plugs from is Takao in Fresno, Takao. However, even though they are, they're using pasteurized media and following, up on benches, foot baths, all of that. When I finally got a list of fungicides from them, I was disappointed to find that they are using pretty much the whole suite of fungicides. And so that's my last AIR. BMP that I have to meet is waiting 60 days to test their plants. So it is difficult, if not impossible, to currently, I don't know of any absolutely clean nurseries following all of the BMPs, the AIR BMPs, best management practices, who don't use fungicides. So that's why we're doing pair testing after 60 days of all of the material we buy in from them.
That's great. So we have just a couple of minutes left before we're going to round out the program. And I'm trying to look through to see if there's any main points that we want to make sure that we do. This is a question I don't know if we can answer, but I am curious about whether or not we can start helping other people in other places. So Talina had asked, I manage a native plant nursery in Washington State. Is the AIR program available for nurseries only in California, or is it something we could participate in also? So I was wondering if Krista and Betty and Ted, if you might give some inspiration for people on how they might start implementing some of these things, form a group to get something like an AIR program started in their own area.
Yeah, I'd like to jump in right at the start. We actually got a call at one point from somebody in Virginia who was running a nursery, who basically said, well, we've been required to follow the BMPs on your site for the production of these plants that are going to be used in this forest situation. And they had some particular question. And there's two ways, at least, to implement this type of program. And one that we've been working with, actually, we really worked on both. One is to set up a program where you have a third party that basically manages the program and runs it. The other way is to do it on a contracting sort of basis, where, okay, a contractor says, okay, we want clean plants. We want you to follow this set of standards. These are essentially your contract standards, or these BMPs. We're going to require testing, and we'll have, if we need to hire somebody from the outside to do the testing, we'll do that, and do it on a contractual basis. So it's something, it's a little different than what Krista was doing there, in that you would basically have them adopt as contract requirements the entire BMPs. So you could do it in the absence of a program that's set up like ours, and ours is not not totally institutionalized to the degree it needs to be yet. You can do it on kind of a client to seller type of basis. Okay, we are contracting for clean plant materials. Here's your standards. Can you follow these standards? Yes. Can you provide the backup testing that's needed to prove that you've got clean material? Then it's kind of a transactional type of thing. And that can be done, you know, without a program in place. Just the expertise that's needed to you know, interpret these things. So a good plant pathologist.
Okay, well, I'm going to use that as our way to sign off since we're now at 4:30. I just want to again thank everybody for joining us today on this virtual seminar on native plant buy-ins. The link to the recording will be emailed to everyone who registered for the seminar and also posted on our calphytos.org website. I'll also try to follow up on any questions that we didn't get to answer live in the session today. Please be in touch with me via email if you have any other follow-up questions, and have a great rest of your day. Thanks, everybody. Bye-bye.
Thank you all.